Hello guys, welcome on Tesla Adventures. In this video today we are going to discuss the concept illustration problems based on the Pascal's law in accelerated frame. So you can see this question number 1. In this question there is a container which is completely filled with the liquid, ideal liquid, and there is no air inside the container, and there are 3 points A, B and C. So we have to find out the pressure difference between C and A, and it is also given in the question that this complete container is being accelerated in forward direction with an acceleration of A naught. This distance between A and B is h, and this distance between B and C is L. So we have to find out the value of PC minus PA. So first of all, we'll do this question by two ways. So by method 1, you can see that if we move from A to B, so we are moving in the direction of mg, gravity. So the pressure at B will be greater than the pressure at A. So pressure at B will be equal to PA plus H rho G. Now you should remember, as we have already discussed previously, that this h is the height between the distance between A and B, and this g is the effective acceleration in the direction of AB. So in the direction of AB, the force acting on the fluid is mg, and therefore the g effective in this direction is g. So now if we talk about pressure difference between B and C, so we can say that the pseudo force will be acting on this container in the backward direction, which is ma naught, and therefore the effective acceleration in x direction, in the minus x direction, will be a naught. So we can say that the pressure at C will be equal to pressure at B plus L rho into a naught. Now if we substitute the value of PB, so PC will be equal to PA plus H rho G plus L rho A naught. So PC minus PA will be equal to H rho G plus L A rho naught, or L rho A naught. So this is the value of PC minus PA by method 1, and obviously this method is the easiest method. Now if we wish to find out the value of PC minus PA by another method, we can directly move from A to C. So while moving from A to C, we can say that PC will be equal to PA plus, now this distance, this is the direct distance between A and C, it would be under root of L square plus H square. So it would be under root of L square plus H square into rho into G effective. Now the effective acceleration in this direction can be written as, now you can see that the effective acceleration in AB direction is G. So the component of G in this direction will be G cos theta, and the effective acceleration in this direction is A naught. So the component of A naught in this direction will be A naught sin theta. So G effective is the effective acceleration along AC, so it would be G cos theta plus A naught sin theta. So PC will be equal to PA plus under root of L square plus H square into rho into G cos theta plus A naught sin theta. Okay, and PC minus PA will be equal to rho and G under root of L square plus H square cos theta plus A naught under root of L square plus H square sin theta. And obviously L square plus H square cos theta is H, and L square plus H square sin theta is L. So obviously this will be this only. This will be H, so it would be rho GH plus rho A naught into L. So this is the same result. Okay, so you can solve this question by both of these methods, but obviously moving will be better. Now let us talk about this question. Let us discuss this question. So in this question, you can see that this is a tube. This is a square tube. Although I have drawn it like a rectangle, but let us assume that it is a square tube for ease of calculation. And this square tube is having different liquids, all four different liquids filled in the different forearms. And this tube is suddenly accelerated with an acceleration of a naught in the forward direction. Due to this acceleration and due to the pseudo force developed, these junctions will shift like this. It will shift in the backward direction, it will move up, it will move like in the forward direction, it will move down. And this shift will be equal in all four tubes due to the fact that a tube has equal area of cross section and all the four liquids are ideal. So what we can do, we have to find out this shift x. So let us see this situation. I have drawn already this situation. Okay, so 1 second. Yes. So now let us assume this point as A, and let us move from A, move away from A, and let us move in a closed loop. And let us come again on A, and let us write the pressure variations. So PA, and now I am moving in the upward direction, so pressure will decrease. So PA minus X into rho into G. This is X rho G. And this is L minus X. So this is L minus X rho, and this is rho 4. So L minus X, this is rho 1. L minus X rho 1 into G, and this is X rho 1. Now we know that the pseudo force is acting in the backward direction and we are moving in the forward direction in this section. So we can say that the pressure will decrease. So this will be minus X into rho 1 into A naught. A naught is the effective acceleration of X direction. This length will be L minus X. So the pressure variation will be minus of L minus X into rho 2 into A naught. Now while moving in the downward direction, pressure will increase. So I can write it as plus X into rho 2 into G. And while again moving from this point to this point, I can write this length will be L minus X. So I can write it as L minus X plus with L minus X into rho 3 into G. While moving in this direction, we are moving in the direction of pseudo force, so pressure will increase. So it would be plus X into rho 3 into G. And while moving from this point to this point, pressure will again increase. So it would be L minus X. In fact, this is A naught. So while moving from this point to this point, it would be L minus X into rho 4 into A naught. And that would be equal to PA, because we have again reached this point A. So cancelling this PA with PA, let us cancel out PA with PA, and let us separate the terms of X. So you can see that what I am doing, I am writing down the terms of X at the left hand side of the equation and terms of L at the right hand side of the equation. So you can see that it would be X will be common. This will be minus rho 4 G minus rho 4 G. This will be plus rho 1 G. This will be minus rho 1 A naught. This will be plus rho 2 A naught. This will be plus rho 2 G. This will be minus rho 3 G. And this will be plus rho 3 A naught and this will be minus rho 4 A naught. And I am writing down the terms of L on the right hand side of the equation. So this term will be positive on that right side, so it would be L will be common, it would be rho 1g and plus rho 2 A naught and minus rho 3g and minus rho 4 A naught. Okay, so you can see these terms and you can find out the net value. So let us write down it on next page. Now you can see that if we take common g, then taking g as common in this equation, so you can see that it would be rho 1 minus rho 4 x into, this is g is common, rho 1 minus rho 4, and this will be plus rho 2 minus rho 3 plus rho 2 minus rho 3 plus taking A naught common, I'm taking A naught common, so it would be minus rho 1 plus rho 2 plus rho 3 minus rho 4 minus rho 1 plus rho 2 plus rho 3 minus rho 4. Okay, so you can see yeah, so this would be the final result, and on the other side of the equation it would be g is common, then it is rho 1 minus rho 3, and A naught is common, then it is rho 2 minus rho 4. So this is L and g is common, rho 1 minus rho 3, and A naught is common, so it would be rho 2 minus rho 4. So x will be equal to L g rho 1 minus rho 3 plus A naught rho 2 minus rho 4 divided by g is common, rho 1 plus rho 2 minus rho 3 minus rho 4 plus A naught is common, rho 2 plus rho 3 minus rho 1 minus rho 4. This will be the final answer. So you don't have to worry, because this is a quite lengthy question because of the variables given in the question. But in actual question, the variables would be given like rho 1 will be given as 2 rho and rho 3 will be rho, like this. So the calculation will be easy in the actual question, and in such questions in which they are having some lengthier solution, then you should always focus on the concept which is being taught in the question, not on its solution. Yeah. So now let us discuss another problem, this one. This is the similar problem in which there is an equilateral triangular tube in which all the three tubes have equal length, and this complete tube is accelerated in the forward direction with an acceleration of A naught. Due to this acceleration, these junctions will again shift like that, and we have to find out the value of this shift. So I've again drawn this diagram. So you can see that if this tube is accelerated in the forward direction with A naught, and let us suppose that this point is A, then we can say that the pressure at A is PA. Then if we are moving in the upward direction, we have to take this height, and this height will be x sine 60. Okay, so this is rho 3. So pressure, we are moving in the upward direction, so pressure will decrease. So PA minus x into rho 3 into sine 60 into g. So this is g, and sine 60 is root 3 by 2. Okay, when we are moving in this part like that, so you can say that this length will be L minus x into root 3 by 2. So again it would be a minus of L minus x into rho 1 into root 3 by 2 g. Then we are moving in the downward direction, so it would be plus rho 1 into x into root 3 by 2 g, and then we are moving in this downward direction, so it would be plus rho 2 into, this is L minus x, so this is L minus x into root 3 by 2 into rho 2, in fact it would be g. And when we are moving in this section, then obviously we have to take these lengths, and in the direction of pseudo force the pressure will be increasing, so it would be plus x into rho 2 into a naught, and it would be plus rho 3 into L minus x into a naught. That would be equal to PA. Now again cancelling PA with PA. Now separating the terms of x and L, we can write it down here. Yes. So you can see that if we take the common if we take common x from these terms, so it would be x will be common, and it would be minus rho 3 into root 3 by 2g minus root 3 by 2 rho 3g. It would be plus rho 1 root 3 by 2g plus rho 1 root 3 by 2g. It would be root 3 by 2 rho 1g again plus root 3 by 2 rho 1g root 3 by 2 rho 1g, and it would be plus root 3 by 2, in fact minus root 3 by 2 rho 2g. So it is minus root 3 by 2 rho 2g, and this will be rho 2 a naught, and this will be minus rho 3 a naught. So it would be plus rho 2 a naught minus rho 3 a naught, and this will be equal to the terms of L. In the terms of L, at that side this term would be positive, so it would be rho 1 into root 3 by 2g, so L is common, rho 1 into root 3 by 2g, and this term will be minus rho 2 into root 3 by 2g, so minus rho 2 into root 3 by 2g, and this term will be minus of rho 3 a naught minus rho 3 a naught. So x will be equal to L and bracket of root 3 by 2g, this is rho 1 minus rho 2 minus rho 3 a naught divided by these terms. So if I take g common and root 3 by 2 common, so root 3 by 2 g is common, and it is minus rho 3 plus 2 rho 1 minus rho 2. 2 rho 1 minus rho 3 minus rho 2 plus, if I take a naught common, then it would be rho 2 minus rho 3. Rho 2 minus rho 3, taking common a naught. This will be the value of x. Now let us discuss this question. In this question, you can see that this is a container which is moving with an acceleration of ax I cap plus az k cap. And this is z-axis, this is x-axis, and the y-axis is inside this plane. the density of the liquid is rho, and it is given that the pressure at origin is P naught. So we have to find out the pressure at a point which is having a coordinates of x comma y comma z. So obviously we know that the pressure is not changing in y direction, because y direction does not have any force acting in it, and the pseudo force acting will be in the downward direction, MAZ, plus another force will be mg in the downward direction, and a pseudo force will be acting in the backward direction, which is max. So if there is a point, let's suppose P is a point which is having a coordinates of x comma y comma z, then we can say that the pressure at P will be equal to P naught, which is the pressure at origin. And now when we are moving from origin to P, then we are moving in the opposite direction of both pseudo forces. So the pressure will decrease. So we will write minus of the G effective in this direction. G effective will be equal to AZ plus G, and G effective in this direction will be AX. So minus of rho into AZ plus G, and the distance traveled in Z direction is Z, and minus of rho into AX into the distance traveled in the X direction is X. So this will be the pressure at this point P. Now we move on the next question. In this question, you can see that there is a open L-shaped tube which is having some liquid filled in it, and this tube is being rolled on the rollers. These are the rollers, you can see. These rollers are the pure rolling spheres, and the length of this tube is A, and this is the liquid filled in the tube. Now amazingly, the liquid is not coming out from the tube from this open end, and to keep the liquid safe in the tube, we have to move the tube with some acceleration, and this is done by rolling it on the spheres, smooth spheres on the ground, which are rolling on the ground. So we have to find out the minimum value of A so that the liquid does not comes out. So let us see the situation that if this point is A, this point is B, it is just inside the liquid. So we can say that and the pressure at this point is P naught. So we can say that the acceleration of tube will be equal to 2A naught 2A, because it is rolling on the top of spheres, and in pure rolling we know that if the centers are moving with an acceleration of A, then the top point will be moving with the acceleration of 2A. So the acceleration of tube will be 2A, and obviously the pressure at A will be equal to P naught plus H rho G by this, and the pressure at A will be equal to PB plus L rho into 2A. This is L rho into 2A, because pseudo force will be acting in the backward direction, which is 2MA. Now as the liquid is not coming out from this end, we can say that PB will be equal to P naught. So PA will be equal to P naught plus 2L rho A. And if we compare it with this PA, so we can say that P naught plus H rho G will be equal to P naught plus 2L rho A. So cancelling P naught with P naught, A should be equal to Hg by 2L this, yeah. So Hg by 2L. A should be equal to Hg by 2L. This is the value of minimum acceleration required for the spheres, so that tube does not lets go the liquid out of it. Thank you.